Okay, this is the video for the notes lecture for volume of rectangular prisms and pyramids. So, essential questions for this set of notes. What does the volume measure and how, what does volume measure and how is it calculated? Number two, how is the volume of a rectangular prism, this should not be cylinder, but pyramid, make that amendment to that, and how do you label the units of a volume measurement? Okay, so starting things off here. Volume is a measure of the amount of space an object takes up or can contain within it. Okay, so now we're talking about a three-dimensional measurement, right? So here's a container, little Tupperware, and so the volume of the container can be thought of in two ways. So it's taking up some space in the room right now, and so that's three-dimensional space that it could be taking up. Also, I can think about volume as how much space it has within it. So I could find the volume of this container to see how much it could contain within it. So volume is found by multiplying the base area, which could be abbreviated BA, capital BA, or sometimes it's just noted as just capital B when you're seeing it in text. So it's the base area, so whatever the base of the object is, the area of that, that we're multiplying by the height of the object. And so in general sense, for the volume of any figure, we're going to be multiplying base area times height, or again, sometimes base area is just capital B, and so you might see it as just base area times height like that. And as I just said a second ago and showed with the Tupperware, it is a three-dimensional measurement, and so because it's now a three-dimensional measurement, and we're not just finding a two-dimensional space like with area, a three-dimensional measurement means that we are going to need to cube our units, which means raising them to the third power. So instead of putting a little 2 like we've been doing for area, after we get our units, whether it be inches, feet, meters, we're going to need to raise those to the third power now and put a little 3 as an exponent on our units to give the proper measurement here. So volume of a rectangular prism first. So in a rectangular prism, again, we can think of these commonly as like a box, right, is what a rectangular prism is. The formula for finding that then, what we're going to do is the base area for this is a rectangle, right? So the bottom has a rectangle that has a length and a width. So we're going to multiply those together to get the area of the bottom rectangle. And then we multiply it by the height. And so the height being vertically up this way. Now, something that some students kind of stress out about is which one do I label length, width, and height? Well, again, since we're multiplying all those things together, it won't matter really which one you call which. As long as if you identify that there's 3 different measurements being given for length, width, and height, that you're using those 3 different numbers for those. So, examples down here. We have 3 rectangular prisms or boxes that we're finding the volume of. And so on this first one, again, I have on the base, the measurements of length and width there are 6 and 19. If I call the length the measurement across the front and the width the measurement down the side, that's fine, or I can reverse those and still get the same answer. My height given over here is 7. And so again, for volume, we do length times the width times the height. So here for this one, that would be 6 times 19, as I labeled it, times 7. But had I done the 7 first and switched that for the width, I'm going to get the same answer, right? Because multiplying those in any order will work. So 6 times 19 times 7 gives us 798. So my volume here, I can write my answer down below here or put it up on the line either way. 798 is the number. Meters was the measurement, but remember, this is volume, so now what we're going to have to do is put cubed on that, or raise it to the third power. Okay, for number 2, this time I'm given a length up at the top as 11 feet, a width 4 feet, and a height of 18 feet. Multiply those three numbers together. 11 times 4 times 18. And we get 792. Measurement was feet, and then cubed because it's volume. Okay, one more. You can call the 6 the length. 2 can be the width. And the height is 3. So 6 times 2 times 3. Okay. Notice that I'm just multiplying 3 numbers together here. Sometimes additional measurements are given. So sometimes, like, this is also labeled 6 up here. This could be labeled 2. There could be another height measurement given over here of 3. So there's times where they put additional measurements given just to show on the different sides that it's the same all the way around. But remember that you're really only multiplying together 3 numbers. So just finding a number that will represent the length, finding a number to represent the width, finding a number that will represent the height, just multiply those 3 numbers together. Okay, so it's not like perimeter where we add up all the sides and the number of sides determines the number of numbers we add. Here it should just be 3 numbers we're multiplying each time. Okay, so 6 times 2 times 3 gives us 36. Centimeters was the measurement. Cube it for volume. Okay, sliding over to be able to answer our column question here. Number 1, what is the name of a rectangular prism that has the same measurement on each side? There's a diagram of it right here. So if the length, the width, and the height are all the same across there, again, we should recognize this figure from when we were talking about surface area for rectangular prisms, but that would be a cube. And so how could you rewrite the volume formula for the above question, or the figure in the above question for the cube? So our volume, it's still a type of rectangular prism, so it's still length times width times height, but what you notice here is that for the length, width, and height, that all 3 of them would be the same measurement. So they could all be represented with S as it's shown here. So really that would be S times S times S, or another way to simplify that in mathematical terms would be S cubed. And so this is why we call it cubing the number when we raise something to the third power, is because the mathematical measurement for finding the volume of a cube, you multiply the side by itself three times total, and that makes a volume for a cube. Okay, next we are going to talk about volume for a pyramid. So for a pyramid, and I'm going to try to put a link to it on this video if I can figure out how to do that, and if I can get that advanced. I'll definitely post it in Google Classroom. But it's kind of neat to go ahead and watch a YouTube video for showing the proof for the volume of a pyramid. But the idea is if I take a pyramid that has the same base area as a rectangular prism, so I could extend the sides up around here and close this off and make either a cube or a rectangular prism that has that same base, the pyramid is going to be 1/3 of the volume of the rectangular prism with the same base. Okay, which means that if I had a pyramid, and this is what the video shows, and you fill it with something, and then you add 3 of those to a rectangular prism that has the same base measurements, then it takes 3 of them to be able to fill that rectangular prism. So that means for our volume formula, it's going to be the same idea as length times width times height, except in this case it's 1/3 of that. So 1/3 times the length times the width times the height would give us 1/3 of it. But multiplying by 1/3 is the same thing as dividing by 3. So sometimes I think that that's maybe the easier way to go about it. So length times width times height, and then if we divide that by 3. And so this one over here happens to be the one that I think is a little bit easier to use. It's just more user-friendly to put it in the calculator as well, to do it that way. Now, if your base of your pyramid was not a rectangle, say it was something like a triangle or a hexagon or a pentagon, you would have to use a different formula than this. Kind of the general formula that always works is it's 1/3 the base area times the height. Okay, but in this case, we're going to be primarily focusing on ones that are rectangular or square bases, and so because of that, the length times the width times the height works, because that will give us our volume of a rectangular prism of that same base, and then divide that by 3 to get to the measurement of the volume of a pyramid. Okay, so next, another bullet point there to point out. It says, notice that the h, or the height measurement, is now the overall height of the pyramid and not the slant height. So remember when we did the surface area for pyramids, the slant height was what we needed because we were finding the area of this triangle on the outside. But now when I'm talking about the height of the overall figure, notice that this height measurement, it measures, as it says here, from the base to the peak. Okay, which the peak is up here at the top. So notice that this height measurement that we're being given, and it makes a 90-degree angle down here, which means it's perpendicular to the base. So just like when we need to find the height in a triangle, we have to make sure that that height is perpendicular to the base. So here, same idea. So when we measure the height, we want it to be all the way from the bottom of the pyramid to the highest point in the pyramid, which we call the peak, or the vertex is another name for that as well. Okay, so for our examples here, finding the volume of each pyramid that's listed below here. So if I call this length, this width, and then this is the height of my pyramid, again for volume, now it's going to be length times width times height, and then divide that by 3 because it's 1/3 of it. So for this one, 6 times 8 times 7, and then divide by 3. And 6 times 8 times 7 makes 336. Divide that by 3, and we get 112. Feet was the measurement. It's volume, so cube that, and so 112 cubic feet. Okay. If you happen to get decimals, I think on the worksheet it directs you to round to the nearest tenth on those. So just be rounding those if you get long decimals. Okay, number 2, same idea. Call that the length. This is the width, not the height. Multiply the 3 together. 3 times 4 times 7. Divide that by 3. Okay, and for this one, it comes out to be 28 feet cubed, or cubic feet. Okay, so that's finding volume of a pyramid. Again, 1/3 of the rectangular prism that would be created from the same length, width, and height. So just multiply length, width, and height, and then divide by 3. Okay, next, the conclusion questions. So, conclusion question number 1 says, describe how the volume of the shape would be calculated, then calculate its volume. So this shape that we have here looks a little bit different. This time it's a prism, but instead of being a rectangular prism, it's actually a triangular prism. So the bases that would be on each side here are triangles. And so remember to find the base area there. Instead of finding the base area being a rectangle where we would do length times width, now it's a triangle. So if you remember, the volume of that would be base times height, and then divide by 2. Sorry, for the area. And then after I find that, that would give me my base area here. And then I want to multiply that by the overall height of my triangular prism, which in this case would be the 5. So this is my base of my triangle, height of my triangle there, and then this is the height of the prism. So if I wanted to get more specific here, I could call this like H1, and this could be H2, so that I know which one is which. Here. Okay, so it would be 3 times 1.5, and then divide that by 2 to get the area of the triangle, which is our base here, and then multiply that by the height of our overall prism, which is 5 centimeters. Okay, this gives us 3 times 1.5, divide that by 2, and that's 2.25. Then we need to multiply that by 5, and we get 11.25. It was measured in centimeters and cubed for that. Okay, so again, the any volume measurement is calculated, well, for ones that are prisms or pyramids. It's the base area times the height. Okay, something that's like a sphere, there's a different calculation where it wouldn't necessarily be base height, area times height, although it's something similar to it. Okay, number 2, reasoning. Do the solids have the same volume? And explain. So our solids here, they don't have numbers that are being labeled with them, but they have variables instead. So if I label things here, I have x, y, and z being my length, my width, and my height. So the volume of that would be just that, x times y times z, if I were to substitute those in. So really for the first one, x, y, z. For the other one, it's a pyramid, so volume for that, length times width times height, but then divide by 3. And so if x is my length, my width is y, and my height is 3z this time. Well, if I put those in, that would be x times y times 3z, but then remember I have to divide the whole thing by 3. And so what this would end up equaling is 3xyz over 3. But if I multiply by 3 on the top and then divide by 3, these are going to cancel out. And so what we end up finding is that, yes, these would have the same volume. Okay, and that's being shown by the work that I've given. Okay, and then in summary, so volume is a measurement or a measure of the amount of space that is contained by an object or that an object takes up. The volume of any figure can be calculated by multiplying the base area by the height of the figure. The units used to label a volume measurement are always cubed because the measurement is in 3 dimensions. Okay, completing the chart to summarize the formulas for things. So a labeled sketch of each figure first. So a rectangular prism. To draw that, we can make a rectangle. Add the L of another rectangle there, more in the background. Feeling like Bob Ross here, drawing birds. Length, width, and height then, to label that. And then for our volume formula, remember that it's just multiplying those 3 things together. So length times width times height. For a cube, I want to make it a square. Close to a square as I can make it there. And then again, add my little L bracket there in the back. Finish that off to try to make it look like the sides are all the same around. Technically, it's still length, width, and height, but remember they're all going to be the same for this one, so we can just call them something like S for side. So they're all three the same, which again, remember, means that you can just do side times side times side, or that would be the same thing as S cubed, multiplying the number by itself 3 times. For a pyramid, okay, can make my base, and then going to converge. My 3 at the same point there. Okay, so length, width, height for my pyramid. And so the volume for that one, length times width times height, and then divide it by 3. Okay, hopefully that explains the volume calculations now, and you can go complete the worksheet. Quiz will be posted up soon as well, and get the quiz completed and submit your answers to the form.